Good evening, guys. So next we'll discuss about how design thinking can be applied for when we are able to design an IoT and a web server. So the task here is we need to design a web server which is lightweight as well as user friendly. So with this consideration, let us discuss how design thinking can be applied and what are your inputs on each stages of design. So let us start with empathy.
In design thinking, the empathy is the first stage we are going to discuss about. In empathy, in IoT, the main users are developers, embedded engineers, and the startups and the companies. These are the users, those who use very small devices with limited CPU, memory, and power. So these users need a lightweight web server that can run on such devices. Unlike heavy servers like IAS, which demand too many devices. Industries like smart home, agriculture, industrial IoT, and automotive devices depend on the real-time data access. So the server must be fast and efficient. So high resource use means traditional servers consume too much memory and CPU. Slow response times means real-time performance will be suffer, and energy efficiency means trains quickly, and security overhead means extra processing makes devices even more slower. So by empathizing with these users, we can design a lightweight and energy efficient web server that truly meet our needs. So I defined the second stage. We defined by the lightweight web server. Web server it uses the colors and text to enhance the images, but it also reduces the graphic designing in needs of high efficiency and low memory usage, and it also uses the reliable communications for resources like entertainment and usability of security. Hello everyone, I am going to talk about the ideal phase. In this ideal phase, it uses AI-driven asynchronous architecture instead of multi-threading, and it also it incorporates lightweight security systems, and then it implements defect compressor to reduce the bandwidth usage, and then it incorporates optimized TLS for security purpose, and then minimize the dependencies on the libraries to avoid the bloat system. It also uses ESP35 for ESP32 for embedded servers, and then it uses light TPD for higher scalability, and then it hybrid model which edge catching can be safeguarded.
We'll tell about the prototype part. So here it includes the hardware and the software part. The hardware then includes the STM32 and also 8266 ESP part. So why we are using STM32 means it supports both the C++ code and also the HTML part. And the ESP8266 is used for mainly the Wi-Fi connectivity. So the input data is acquired from the STM32 and then sent via UART to the ESP8266. So from the ESP part, the Wi-Fi is enabled. The Wi-Fi connectivity is done either by code or inbuilt libraries. So here in the library, the Wi-Fi is connected through a local router by the SSID and the password. So when it's connected to the router sends the IP address through DHCP protocol. That's a dynamic host controller. In this configuration, a router can create a perfect MAC address to our devices. This server contains two types of process. One is the request and response process. This request process to our frontend like HTML file. You can use the frontend part into HTML more efficiently, like using a lightweight tags and meta tags, and make that files into separate files. In this file, into converting into the perfect protocols to connect with the servers, and the server will again showcase the frontend. So basically, what we have done is first we need to understand what actually is solution which is required in the community, right? So that is the empathy part. So since we are focusing on a lightweight web server, we need not concentrate more on the UI UX part. So we can eliminate the high graphics or animation images required, and we can concentrate only with the text as well as colors to be displayed. And again, since it is a lightweight, we need not use any other high-level frameworks like React.js or Node.js or any other databases for front end and back end. That is highly complicated, right? So with that, eliminating that part, we just come to using a simple STM32 controller where we program the HTML web page. Right? We write the HTML content for the web page, which is then sent through UR the ESP8266. So that ESP8266 is just controlled using AT commands. It is going to act just as a Wi-Fi modem. Right? So once the IP address is assigned, we are going to host that IP address in the browser, right? So that once that browser gets the IP address, it sends a request to the device, and then the HTML content is going to be displayed. So we can create any number of pages and responses as we required for the particular application. So why we have discussed this is so instead of initially when given a problem statement, what you guys will do is okay, you're going to use front end React, whatever maybe, but whether it is actually required for this application. That's to be initially done through empathy part. Only after that we can go to the prototype stage. Hence, what would have happened is we would have used more high-end frameworks, and finally it turns out to be everything is not required, and it actually is a waste of time. Suitable, right? So that is where design thinking comes into effect. Not just for this application, but for any product design or any application you're going to do, please try to apply design thinking here. Thank you. Nice.